In this lecture, we will be seeing another example of conversion of Mealy machine to Moore machine. So here is our question. Convert the given Mealy machine that gives the 2's complement of any binary input to its equivalent Moore machine. So here we have a Mealy machine given, and what this Mealy machine does is that it takes the binary input string and it gives the 2's complement of that binary input string as the output. So we have designed this Mealy machine in one of the previous lectures and we know how it works. It takes the binary input from RHS to LHS and then it gives the 2's complement of that string as the output. So our task is to convert this to its equivalent Moore machine. Okay, so let's see how we can do that. So before we start, let's know what are our inputs and outputs. Here our inputs are 0 and 1 and outputs are also 0 and 1. Okay, so how do we start? We start with the starting state, that is state A. A is my starting state or the initial state, and we see that A on getting input 0, it goes to A itself and gives the output 0. So what I can do, I can associate the output 0 to this A, and I can say that when A gets the input 0, it goes to this A itself, and we have associated this output which was in this transition over here to the state. So A goes to A itself on getting input 0 and output 0 is associated with A now. Okay, now we have mentioned what happens to A when it gets input 0. What about it when it gets input 1? So when it gets input 1, it goes to B and the output associated is 1. So here I'll make state B and I'll send A to B when it gets the input 1 and the output was 1 over here. So I will associate this output 1 to state B over here. So let's say it gives output 1. Okay, so we have completed A. Now let's come to state B. State B on getting input 0, it goes to B itself and gives output 1. So what I can do is I can say that when B gets the input 0, it goes to B itself and it should give output 1, and output 1 is already associated to this state B. So I can send it to this B itself. Now what about it when B gets the input 1? When B gets the input 1, it goes to B itself and it should give output 0. But if I send it to this B itself, I have to associate this 0 as an output to B, but this B already has an output 1 associated to it. So what I have to do, I have to make another state for B here, and let me call it B0 and let this be B1, and I will associate the output 0 with this B, and I'll say that this B goes to this B over here, which I call it B0 when it gets the input 1, and it should give the output 0 and it gives the output 0. Okay, so now we have completed for state A and this state B1. Now are we done? No, we are not done, because now we have a new state here, B0, and we did not mention what happens to B0 when it gets input 0 and 1. So let's see what happens to B0. In order to complete B0, we have to use this state B over here, and we see that B on getting input 0, it goes to B itself and should give output 1. So I will send this B to this B1 over here when it gets the input 0. I'll send to this B1 over here when it gets the input 0. And why did I do that? Because when it gets input 0, the output associated should be 1, and this B1 has the output 1 associated to it. That is why I send it this way. And then when B gets the input 1, what happens? It should go to B itself and give output 0. So what I can do is I can send this B0 to this B0 itself when it gets the input 1. Why? Because it should give output 0 and this B0 already has an output 0 associated to it. So now we have completed the Moore machine. So this is the Moore machine for the given Mealy machine. Now let us just see if this is working. So for that, let us take an example. Let us say that we want to find the 2's complement of this number 10100. So how do we find the 2's complement? First we have to convert it to its 1's complement. How? Just flip the bits 0, 1, 0, 1, 1, and then add 1 to this. When you add 1, what do you get? 1 plus 1 is 0, carry 1 plus 1 is 0 again, and carry 1 plus 0 is 1, and this 1 and this 0. So this is the 2's complement of this number. So let us pass this string to our Mealy machine and also to our Moore machine and see if we are getting the 2's complement. So first of all, let us pass it to our Mealy machine and see if it is working. So here I'll do it for the Mealy machine. In the Mealy machine, I pass the input string 1, 0, 1, 0, 0. And as we already know that we have designed this Mealy machine in such a way that it should take the input from the RHS and go this way to the LHS. So we start with our starting state A, and A on getting input 0, what happens? It goes to A itself, and what is the output that it produces? 0. And then the next input is 0, and we are in state A. State A on getting input 0, it goes to state A itself and produces the output 0. And now we are in state A and get this next input, that is 1. A on getting input 1, what happens? It goes to B. It goes to B, and what is the output it produces? It is 1. And the next input we get is 0, and we are in state B. In state B, when you get 0, what happens? It goes to B itself. And it produces the output 1. Okay, and now we are in state B and get the input 1. And in state B, when you get the input 1, it goes to B itself, and produces output 0. So this is the answer that we get, 0, 1, 1, 0, 0. And check it from this, 0, 1, 1, 0, 0. So we are getting the 2's complement correctly. Now let us do the same thing for the Moore machine. Now here I'll do it for the Moore machine. So the same input we pass, 1, 0, 1, 0, 0. So in the same way, we start with the starting state, that is state A, and before we get any input, when we just start with state A, there is an output 0 associated to state A. So it gives this output 0. Alright, and then we get the first input, that is 0, and when A gets the input 0, it stays in A itself, and what is the output that it gives? It gives 0. And then we get the next input, that is 0. We are in state A, and in state A, when you get the input 0, stays in A itself, and what is the output given by A? It is 0. Okay, now we get the next input, that is 1. Where in state A, when you get input 1, it goes to state B1. And what is the output produced by state B1? It is 1. And the next input we get is 0. We are in state B1. In B1, when you get 0, it stays in B1 itself. And what is the output B1 produces? It is 1. And now we are in B1 and we get the next input, that is 1. And in B1, when you get the input 1, what happens? It goes to B0. And what is the output produced by B0? It is 0. Okay, so when we run the same thing for the Moore machine, we see that the output that we get is 0, 1, 1, 0, 0, 0. Here it is 0, 1, 1, 0, 0. So we see that our answer is up to this, and there is one extra bit produced by this Moore machine. So we cannot say that they are exactly the same. This Mealy machine and Moore machine are not producing the exact same result. Why? Because Moore machine always gives an extra bit for the output, because there is a output associated to the starting state which will always be given even before it gets any input. So if you want to make it exactly similar, you can just ignore this extra bit that you get in the Moore machine. So here we have converted this Mealy machine that gives a 2's complement as output to its equivalent Moore machine. So I hope this was helpful. Thank you for watching and see you in the next one.